I'm Ms. Jackson coming to you with another video.
Alright, let's look at y equals 3 sine x graph. Again, the parent function or the parent graph is y equals sine x. The original form of a sine graph is given by the equation y equals a sine of bx plus c plus d. And I will actually explain what a, b, c, and d are as I continue to create my videos. So the letter A, or the value for A, is always in front of the sine or the trig function. So that means that this is going to be my amplitude, but I have to take the absolute value of that because the A could be negative. So the absolute value of A is the amplitude. Okay? And I just put amp for amplitude. So if the absolute value of A is greater than 1, then the graph will experience a vertical stretch. If the absolute value of A is less than 1, then the graph will experience a vertical shrink. And if there's a negative in front of the A, the graph will flip over the x-axis. Okay? So in this particular example, we do have a b, but that b is equal to 1 because the coefficient of the x variable is 1. We don't have a c or d, so we're not going to be concerned about the c or d right now. So I know that a is 3. I know that b is 1. So the absolute value of 3, which is our amplitude, is actually 3. Our period is 2 pi divided by the absolute value of b. Again, b is 1, so that would be 2 pi. All right, since my period is 2 pi, my y equals 3 sine x graph will have the same angles as my parent function. So I'm going to go ahead and actually draw those angles on a coordinate plane. Alright, so again, I have my graph drawn, and I have 0 pi over 2 pi, 3 pi over 2, and 2 pi as my angles. And since I have a vertical stretch, because my amplitude, the absolute value of my amplitude is greater than 1, I have a vertical stretch. And the y values are going to be stretched from the original parent graph. So if I created a t-table, I like to make tables because it's easy to understand the graph. So my x values would be 0, pi over 2, pi, 3 pi over 2, and 2 pi. And again, my y values would be my function 3 sine of x. So if I find the first y value, would be 3 times sine of 0. So you would find the sine of 0 first, and the sine of 0 we know is 0, and then multiply it by 3, and you're going to get 0. So at 0, 0, I have a point there. And then I substitute my next angle in, and that's 3 sine of pi over 2. And if I go and look on my unit circle, sine of pi over 2 is 1. And 3 times that 1 is going to be 3. So I go to pi over 2 and I plot my 3. All right, my next angle is pi. So it is y is equal to 3 times sine of pi. Well, I know that the sine of pi is 0. So 3 times 0 is 0. So at pi, I'm going to be at 0. All right. Y equals 3 sine of 3 pi over 2. Again, I'm substituting my angles in for my x in my equation. So the sine of 3 pi over 2 is negative 1. So 3 times negative 1 is going to give me negative 3. So at 3 pi over 2, I'm going to be at negative 3. And then my last value is 3 sine of 2 pi. And the sine of 2 pi is 0. So it would be 3 times 0, which is 0. So if I trace this graph, it's going to look something like this. This is not drawn to scale because I know this is not perfect. All right, so this is my graph of y equals 3 sine of x.